Okay, so we're doing phase 3, lecture number 3. And this one is on compound interest. So we only have 3 to go. Not bad. So before we do that, same as before, when I looked at simple interest, I'm just going to do a little intro, and this time I'm going to introduce the geometric sequence. So, simple example. Find the next number in the sequence or complete the pattern in 2a, 32, 128. What's the next one? Now they grow pretty quickly, so adding the same thing every time is just not going to do it. What could I do instead of adding? Multiply by 4, it seems, for this one. 2 times 4 is 8. Does that still work? 8 times 4 is 32. 32 times 4? Yeah. Sure. So if I follow this pattern, what is the next number?
512.
512. So I get a different type of sequence, and I can continue if I want to. What about the following? Over here, 1, 3, 9, 27. What's the next one? Or what is the pattern?
3.
Multiply by 3. So just something else, not necessarily adding. I'm going to go with 81 here, and you can continue if you want. So we call a sequence like this, where I multiply by the same number to go from one to the next, geometric sequence. So geometric sequence, geometric sequence with, now I need to know, again, where do I start? Let's call it A again. And I don't have the constant difference. I have this number that I multiply by, I call that the ratio. R for ratio is a sequence of the form. Starts with A. A. Then A times that number, maybe a 4, maybe a 3, doesn't really matter. Then this times R is going to be A times R squared. We're going to move the R squared. And I can continue like that. AR cubed, and however far I want to go. So if I start with a 0, and this is then my first term in the sequence, my second, my third, what would be the expression? Move this in a little bit. What would be the expression for the nth one, or the nth term in the sequence? If I give you the position, how do I find, what's the formula, what is the rule that links this expression to its position?
AR to the power of n.
A times R to the power of n. So I have a slightly different sequence, and this guy grows much faster than the arithmetic one, because every time I multiply by a certain number, so it's going to grow much faster. And it's called a geometric sequence. Okay, let's go back to compound interest. this is definitely the more practical type of interest that you see all the time. Simple interest is just my introduction. I have to do it at some point, but maybe not very practical. Compound interest. What would you say is compound interest? Have you heard of compound interest before? I'm pretty sure. Oh. If you have a friend and they ask you what compound interest is, what would you say?
The interest compiled over a period of time.
Say again?
The interest compiled over a period of time.
The interest compiled over a period of time. So I want to avoid as much terminology as possible. So I just want to get the idea. So here it becomes important, what is this period of time that I'm talking about? It could be a year, could be a month, could be a quarter of a year, and so on. So it becomes important, what is my period that I'm talking about? Maybe not necessarily a year. So then, like you said, the interest is calculated at the end of every period, calculated at the end of every period, and then added to my amount. And then I get interest. Let's suppose it's an investment. I start with an initial amount and reach the end of my period, let's say a month. Interest gets calculated, and I get that money added to my original amount, and then I get interest on this new amount. So I get interest on my interest, in a sense, and it's compounding because of that. So let's say here I get interest on the whole new amount. So it's not like simple interest where the interest is calculated separately and only given to me at the very end. At the end of every period, the interest that I get gets added, and I get interest on that whole new amount. So my money is going to grow much faster because of this compounding interest. Everyone happy with the idea of compounding interest? I don't want to assume that you have heard of this before. I'm hoping, being in the business program, you probably would. Compound interest? Everywhere.
Am I happy with it? No. Am I going to deal with it? Probably.
Okay,
We're
fair
going to get
enough.
over it, right?
This is probably as realistic as it gets. Simple interest, I don't know which places you can still use simple interest. But compound interest, if you have a savings account or anything, you take out a car loan or anything, all the interest is compound. So let's look at an example. Example 1. So, because it's a more complicated way for my money to grow, if I think of it in terms of an investment, I need to look at the simple examples first and try and come up with a formula for how to calculate my amount and how it changes. So let's look at example 1. Determine the accumulated amount for an investment of $2,000, 5% compounded annually for 10 years. But let's break it down first and look at the start. I call that position 0. My amount is just 2,000. I start with 2,000. Then, now I'm working in years. Eventually I want to know, what do I have at the end of 10 years? But let's do 1 year at a time. So at the end of year 1, how do I calculate how much money I have? Now it's 5% that I get at the end of year 1. So I get my 2,000, and that gets increased by 5%. That's our short way of having 2,000 plus 5% of 2,000. What's my new amount? Now I want to write it like this, otherwise it just gets messy. Everyone happy with that? There's a reason we did that 2 lectures ago, so because we want to use it here. I don't really care what that amount is, but you can calculate it if you want. I'm trying to leave it in a more detailed form so that I can come up with a formula when I see how my money grows as the years go on. What do I do at the end of year 2? Now, that new amount, let's calculate it. What is this amount?
2,100.
How much?
2,100.
Oh. Oh, okay. Still a little sick. I can't do arithmetic, but I'm sick. Or when I'm healthy, right? So what happens now between the end of year 1 and the end of year 2? This amount now set for a year. So this is going to get 5%. So I have my 2,100 that's set for that year, and that gets increased by 5%. But now I'm not going to think of this as 2,100. I want to break it up to see how my amount after 2 years is built up from my original 2,000 and using the 5%. So this is, where did this 2,100 come from? It's 2,000 times 1.05 times another 1.05. So I have 2,000 times 1.05 squared. We're happy with that. Let's do one more year, and then the pattern should be reasonably obvious. At the end of year 3, let's calculate this amount. How much is that? Just to see. I had 2,100. I went up by 100 from 2,000 to the end of year 1. From year 1 to year 2, what do I have?
2205.
2,205? Is that right? So because I started year 2, I guess, with a slightly higher amount that I got 5% interest, I end up getting slightly more than 100 because I get interest on my interest. So how much do I have after year 3 or at the end of year 3? I take my 2,205 and I increase that by 5%. Where does this come from? This was 2,000 times 1.05 squared times this 1.05. So I get 2,000, 1.05 cubed. And if I continue like this, what would I have after year 4? Leaving it in this detailed form, what do you see?
2,000 times 1.05
So the power of 1.05 is linked to the year number. 2 and 2, 3 and 3, so after year 4, without doing all the detail, I just follow the pattern. After year 10, I would have a calculation, 2,000 times 1.05 to 10. So this leads me to, I don't really care what the actual number is, I'm interested in the formula. This leads me to my formula. If I have my original amount, I don't care about the terminology, original amount, P, people principal, my annual interest rate, R, and my number of years, N. So instead of 2,000, it could be any amount that I start with. Instead of 5%, it could be any amount, any percentage. Instead of 10 years, it could be any number of years. What is my accumulated amount, the total amount that I have at the end? It's going to be P times what should be in this bracket. Is everyone happy with that so far? That the original amount, the 2,000, comes in front.
1 plus 3 is
The power is the number of years, but now the interest rate is just the 5%. And it was 1.05 everywhere. So this should be 1 plus R. So here P was 2,000, N was 10, and R was 0.05. So because I'm increasing it by that percentage, I have this 1, but it's not included in the value of R, so I have to have 1 plus R.
So do you want us to show you all that work, or
Not at all.
or just the?
We just needed one example to get to see why that sort of makes sense. If I just pull it out and show it without motivating it, it doesn't feel so good for me. I need to somehow see where does this come from. I might not remember a year from now, but I know it does come from somewhere. It's not just magic and it works for a reason. This I have to remember if you don't already. There's no formula sheet in this course. No formula sheet. So I have to remember these things. And if you're not good with memorizing, like me, I have terrible memory, there is a way to derive it if you really have to. But I'm not going to ask you to do that. I just motivated here and we want to use this. Any questions so far? So I want to remember that. So let's look at what kind of sequence do I get when I look at how my money grows with compound interest. How does my money grow? So if I look at my specific example, I had the start, and I had 2,000. Then that changed to, at the end of year 1, 2,000 times 1.05. And at the end of year 2, I had 2,000, 1.05 squared. Let's do one more year. At the end of year 3, I had 2,000, 1.05 cubed, and so on. How do I go from one to the next in the sequence of amounts? This is multiplied by 1.05. This is multiplied by 1.05, multiplied by 1.05. So I have a geometric sequence with first term, my original amount, 2,000, and the ratio, this amount that I multiplied by, is 1.05. So a geometric sequence grows much faster than an arithmetic sequence because instead of adding, I'm multiplying, so it's going to blow up very quickly. And that's why any place that offers me an investment with simple interest, it's just not a very good idea. Compound interest is going to grow much faster. If I do compare similar numbers, simple interest and compound interest, let's just compare briefly. Compare with simple interest of 5% annually. Then my simple interest formula was P plus P times R times N. My compound interest, I'll just separate them with an S and a C, is P times 1 plus R to the N. Let's make a little table here. If I have number of years N over here, let's say after 4 years, if I do simple interest with 2,005%, of course. Simple interest gives me 2,400. I think we did this last time. Compound interest, 2,431. So it's not a big difference. There's a little more, but it's not that much more. If I go to 10 years, my amount is pretty small to begin with. Simple interest gives me 3,000. Compound, if you put it into the calculator, 3257. So it's still not a lot, you might say, but I didn't start with a lot. But the difference is more. If I go to 20 years, simple interest is just 4,000. Compound interest is 5306. So if you start with a bigger amount, it's just going to have a much bigger difference. The difference is going to grow much faster. Here we said this was linear growth according to a straight line. This one is what we call exponential growth. And the property of exponential growth is the further I go, the faster it grows, because the more interest I get. So the further in I go, the bigger this difference is going to get. And it is worth knowing the difference between different types of interest rates and which ones are good, and why is one better than the other one, long term, and so on. Any questions on this? So even though some of us are quick to say that, oh, I have no experience in business courses, I don't know the terminology, we're avoiding as much terminology as we can because I don't know the terminology either. But when it comes to interest rates, whether you're in a business program or not, it is very useful to know something about interest rates, because at some point you're going to buy something, you're going to want to invest your money somewhere, and the person you're dealing with might try and scam you in some way and not give you all the information, so it's important to know something about how these things work.